Welcome. In this video, we'll explore how to validate IP addresses, both IPv4 and IPv6, using regular expressions, often called RegEx. We'll cover the basics of each IP address format, and then dive into the RegEx patterns used to validate them. Let's begin with IPv4 addresses. An IPv4 address is structured as four numerical sections called octets, each separated by a dot. An example is shown on the screen: XXX.XXX.XXX. Each of these octets has a range from 0 to 255. Essentially, each octet is an 8-bit number. Now let's look at a RegEx pattern that validates an IPv4 address. The pattern is as follows: open parenthesis 250 followed by 0 to 5 pipe, 2 followed by 0 to 4 followed by 0 to 9 pipe, 01 optional followed by 0 to 9 followed by 0 to 9 optional, close parenthesis /dot, close parenthesis curly brackets 3 open parenthesis 250 followed by 0 to 5 pipe, 2 followed by 0 to 4 followed by 0 to 9 pipe, 01 optional followed by 0 to 9 followed by 0 to 9 optional close parenthesis $. This RegEx validates each octet to ensure that it falls within the range of 0 to 255, covering all valid possibilities. Let's see how to implement this in Python. First, import the re module for regular expressions. Define a function, validate_IPv4, that takes an IP address string as input. Inside the function, define the IPv4 RegEx pattern we just discussed. Finally, use re.match to check if the IP address matches the pattern. The function returns true if there is a match, indicating a valid IPv4 address, and false otherwise. Example usages are shown on the screen. Calling validate_IPv4 with 192.168 returns true, and with 256.1 returns false. Now let's move on to IPv6 addresses. An IPv6 address consists of 8 groups of 4 hexadecimal digits. The groups are separated by colons. An example is shown on the screen: XXXX://XXXXX://XXXXX://XXXXX://XXXXX://XXXXX. For simplicity, consecutive sections of zeros can be compressed using a double colon, denoted as : Here's a simplified RegEx pattern for validating full-format IPv6 addresses. The pattern is as follows: open parenthesis open square bracket 0 to 9 a to f close square bracket 1 to 4 close parenthesis curly bracket 7 open square bracket 0 to 9 a to f close square bracket 1 to 4 $. This RegEx checks for 8 groups of 1 to 4 hexadecimal characters, which include digits from 0 to 9 and letters from A to F, both upper and lowercase. Let's see how to implement the IPv6 validation in Python. We again import the re module. Define a function, validate_IPv6, that accepts an IP address string. Implement the IPv6 RegEx pattern we just discussed in the function. Use re.match to determine if the IP address matches the IPv6 pattern. The function returns true if there is a match, meaning it's a valid IPv6 address, and false otherwise. The examples on the screen show how to use this function. Calling validate_IPv6 with a full-format IPv6 address: 2001:0DB8:5A3:0000:000:8, a 2E:0:370:7334, returns true. However, a compressed IPv6 address like 2001:DB8:1 returns false, as this pattern only validates full-format addresses. Now let's create a combined function to validate both IPv4 and IPv6 addresses. First, define a function, validate_IP_address, that takes an IP address as input. Inside the function, define both the IPv4 and IPv6 RegEx patterns that we discussed in previous slides. Use re.match to check if the IP address matches either the IPv4 or the IPv6 pattern. The function returns true if the IP address matches either pattern and false otherwise. RegEx patterns are very powerful for IP validation. You can handle both IPv4 and IPv6 formats with a single function. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.